what time really is and how it connects to energy, mass, and the constants of nature. Einstein once said that time is what a clock measures. It sounds poetic, but what does a clock really measure? Look closer and you'll see. A clock does not measure time at all. It simply changes. The hand moves, the gears shift, something inside reconfigures, and that motion is what we call time. Without movement, there is no tick, and without a tick, there is no time. The clock does not record time. It creates time through its own interaction. Time is change itself. In the UBIT model, this observation is taken literally. Time is not a flowing background or a hidden dimension. It exists only when something changes, when two UBIT-based structures interact and their distance r is no longer constant. Formally, the change in time follows from the change in distance. dt equals frac r2c fx du dr. Here, minus r is the distance between two interacting structures. Fx is their relative interaction strength. Du is the universal UBIT diameter, and c is the maximal potential transfer velocity. Time is thus a ratio, the amount of distance changed, dr, divided by the maximal transfer capacity between the two structures, c, fx, du2. Where interaction is strong, Fx large, dt becomes small, time slows. Where interaction is weak, dt grows, time speeds up. The clock as a physical illustration. A large wall clock with heavy gears contains far more internal interaction than a small wristwatch. To keep both ticking at the same rhythm, the large clock must exchange more energy. Its internal components carry greater structural inertia. The internal Fx per movement is smaller. Every tick costs more energy to maintain the same change of angle. The wristwatch, by contrast, has short internal distances and light components. It needs less energy to maintain its rhythm. Its potential velocity, Vpot, is higher, and its dt per cycle smaller. It simply changes faster. The difference is not symbolic, but structural. Time depends on how much interaction and therefore energy is required to sustain change. Energy, mass, and time. From the same UBD foundation, energy emerges naturally, equals Fx mu squared frac du squared du. At minimum distance, r equals du equals Fx mu2 squared c squared. At maximal interaction, Fx equals 1, this becomes E equals mu squared c squared, which reveals that the familiar E equals mc squared is only a macroscopic projection of this more general relation. The mass we observe is not an intrinsic property of a single object, but the interaction effect between two underlying UBITs. And because Vpot equals dr dt, energy can also be written as E equal Fx mu squared left dr dt right 2. Energy, mass, and time are therefore inseparable. Energy is the capacity for distance to change. Mass is the internal delay of that change. Time is the rhythm of that delay. The falling apple. When an apple falls toward the earth, the two form one bilateral system. There is no separate time of the apple or time of the earth, only the time of their interaction. As r decreases, Fx increases, and dt becomes smaller. Their shared rhythm accelerates. They do not move through time. They generate time by changing their distance. At the moment they touch, r reaches its minimal value du, their relative change ceases, dt to 0, and time for that interaction disappears. There is only structure left. The process that Einstein described as time stopping for light follows from the same logic. When Fx equals 1 and Vpot equals c, no further change can occur. The interval of time collapses to 0. The energy behind the clock. Returning to the clock, the principle is the same. To keep a heavy clock ticking at the same rate as a light one, you must feed it more energy, more tension in its spring, or more weight in its drive. That energy does not make it faster, it compensates for the lower Fx of its structure. Energy and time balance exactly. E, t equals Fx, mu2 v pot r. Every observable interval of time corresponds to a precise amount of structural energy transfer. Larger systems require more energy to maintain the same rhythm, and if that energy is not supplied, their internal time simply slows. Strat time in the universal constant ratio. Now comes the deeper insight. In the time equation, the term du to mu2 appears. This ratio is not arbitrary, it is the universal key that connects all physical constants. The U fundamental relation states frac du squared mu2g mu2c equals frac alpha h 2 pi's equal frac c e squared mu 0 4 pi. Each equality describes the same structural proportion viewed through a different lens. G, the gravitational projection of interaction over macroscopic scale. H and alpha, the quantized projection of the same relation at microscopic scale. C, the scaling bridge between distance and duration. E and mu zero, the electromagnetic expression of the same underlying ratio. Because dt contains du square phi mu sku, time itself inherits this universality. It can be expressed equivalently in terms of any of the constants above. dt frac r2 fx, key dot left, frac 2 pi alpha h c right, drc equals frac r squared, left frac mu squared, c right, dr equals frac rfx stacked 4 pi c2 e2 to dr. Each line represents the same underlying definition of time, expressed through different sets of constants: quantum, alpha hc, gravitational mu gc, and electromagnetic e mu 0 c. This means that gravitational time, quantum time, and electromagnetic time are not different kinds of time. They are the same relational process, measured through different constant projections. A unified interpretation from this viewpoint, energy is the structural tension that drives a change of distance. Mass is the part of that tension stored as resistance, the memory of interaction. Time is the rate at which the tension is resolved through distance. All three emerge from one universal proportion, du squared by mu squared. And because that proportion can equally be written with E, G, H, C, alpha, mu 0, time is universally defined across all scales, from cosmic to atomic, by the same internal geometry of interaction. The simplicity behind it all, Einstein sensed that this unity must exist. He felt that time, mass, and energy were deeply connected, and that the constants of nature were not independent but interrelated projections of one underlying structure. He searched for that connection but never found its explicit form. The UBIT framework exposes what he intuited: not a geometric curvature of space-time, but a structural curvature of interaction itself. Time, energy, and mass are not separate phenomena. They are the different faces of one and the same relational process, the way the universe continuously balances its own change. A clock doesn't measure time, it measures how much energy its structure must exchange to keep changing at a constant rhythm. A planet doesn't fall in time, its fall is time, distance changing, energy transferring, structure rebalancing. V pot equals c dot fx frac du square r squared. That single expression connects every constant, every scale, and every rhythm of the universe. Open quote. Perhaps our clocks don't measure time at all. They simply trace the universe's heartbeat, the pulse of interaction itself. Close quote.